All right, we've got a new formula here. Interest compounded continuously. That is a whole different formula. In order to use this, you need to see that the interest is compounded continuously. So you won't see monthly, daily, yearly, anything like that. You're going to see continuously. That gives you the go-ahead to use this formula here if you see that it's being compounded continuously. All right? P, R, and T are still the same things. P is the principal, the initial amount of money. R is your rate, and T is your amount of time. But then we've got this E here. Now, E is actually just a number. It's like 2.7182, blah, 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 blah. Okay, it goes on forever, doesn't repeat, much like pi. E is a different number that we're going to be using here with our compound interest, or compounded continuously interest formula. Okay? So let's take a look here. Let's say you invest $1. A whole dollar at 7% interest, and it's compounded continuously for 4 years. Continuously compounded. We need to use our APERT formula, as we call it for short. P-E-R-T, get it? Okay, so P is our principal. That means that P is going to be 1. R is our rate, so 7%, 0.07, and T is 4. So if we plug that into our formula, we end up with this bad boy right here. 1 times E raised to the 0.07 times 4. And if we plug that in our calculator, we end up with 1.3231. So we get a whopping $1.32 in 4 years. But look at that. Our dollar is making money. Now just imagine if instead of $1, you put in $1 million. Well, now you're making $320,000. So that's when, your money is making money. Know what I'm saying? So that's kind of cool. If you see, like, okay, well, if you've got a lot of money, that money can make money. You're making some bank there. Over $300,000 if you put in $1 million. So why don't you try this problem here and pause the video, hit play when you're ready to try it, or ready to see an explanation, okay? So we're going to have 2 different formulas here. We got 2 situations. $8,000 for 6 years, and you either do 7% compounded monthly or 6.85% compounded continuously. Which one's better? Well, we got 2 different formulas. Here's our 2, and we're going to go ahead and work both of them. So that first one, I got to plug in my numbers. So here we have our formulas with the numbers plugged in. Now if I plug these both into my calculator, the one over here on the left is going to be $12,160.84. That's how much I have after 6 years. Now the other one, I plugged that in my calculator as well. I'm going to have $12,066.60. So that lower interest rate really hurt us on that one. Even though it's compounded more times, it doesn't catch up to the other investment. Therefore, really our best option is to go with this one over here. Go with the first one, 7% compounded monthly rather than 6.85% compounded continuously. But we can still compare them, which is nice, so you're making an educated decision. Because you end up with an extra almost $100 on the left there.